This chapter is about Master Production Schedule Part 2. In this chapter, I will discuss disaggregation, that is about converting a production plan into master production schedule, developing MPS for different time zones. This is a topic we have already discussed, and then developing MPS with safety stocks. Here are some of the concepts that we have already discussed in previous lectures. The first one was hierarchy, which means we discussed that materials management handling, it starts with strategic business plan and then production plan, and production plan is converted into master production schedule and then material requirement planning. Today we'll be focusing on this part, how to convert production plan into master production schedule. Another topic that we discussed earlier was about production plan, how to make production plan, and one of the formula that we discussed was this one: ending inventory is equal to OPD. O is opening inventory plus production minus demand, and this formula can be tweaked a little bit to make it like this one. This production is equal to ending inventory minus opening inventory plus demand. And then we divide production by the number of periods to get each period's production. And then in MPS, we start with ask yourself a question: if PAB is sufficient to meet the next period's demand or forecast. Here is an example whereby we will be converting a production plan into master production schedule of individual items. Here we have two items, product A and product B, and this is our production plan. And production plan is at the level of family of products, whereby master production schedule is at the level of individual products. Our task here is to convert this production plan into master production schedule of product A and product B. Here is the data. Opening inventory is 270 units, and we can see it also appears here 270 units, and we want to reduce this to 150, which means by the end of period 4 is the last period. So when period 4 ends, we want this 270 to be reduced to 150, which means the amount that should appear here should be 150. For production plan, our approach is to start with the formula: ending inventory is equal to opening inventory plus production minus demand, and this formula can be changed a little bit to calculate production is equal to ending inventory. The required ending inventory is 150 units, then demand is 920, that's a total demand, and opening inventory is 270. That gives us total production is equal to 800. It's a level strategy, so we have to distribute this 800 to 4 periods, which means 800 divided by 4 periods, 1, 2, 3, 4, that will be 200, which means that in each of these periods we'll be making 200. The next step is to calculate projected available balance or PAB. And to calculate PAB, we can use the same approach as we discussed in the last lecture, that was making a semi-isosceles triangle or a broken arrowhead. So which means this 200 plus 270, which is 470, 470 minus 220 is equal to 250. And then for the next period, 200 plus 250 is equal to 450, 450 minus 300 is equal to 150, and then 200 plus 150 is equal to 350, 350 minus 200 is equal to 150. And then 200 plus 150 is equal to 350 minus 200 is equal to 150. Once production plan has been made, then the next task is to make master production schedule for product A and product B. And there are two conditions that must be met. First of all, production for period 1, period 2, period 3 and 4 is 200. Now we want this condition to be respected here, which means total production in period 1 of product A and product B should not exceed 200, which means whatever is the quantity here in period 1 of product A and period 1 of product B, they should not exceed 200. Similarly, the total of production in period 2 of product A and period 2 of product B should not exceed 200. The same thing also applies to period 3 and period 4. The second condition is that ending inventory should be 150 units. So which means when period period number 4, which is the last period, when it ends, the ending inventory should be 100, which means the combined one. Here, the inventory that's here and the inventory that's here, it should be 150. In order to develop master production plan for product A, our approach is that we ask ourselves, is this PAB sufficient to meet the demand for period 1? So is 120 sufficient to meet the demand for period 1? Yes, it is sufficient. So which means we don't have to produce anything here. And our projected available balance will be 0 plus 120 is equal to 120. 120 minus 120 is equal to 0. So our projected available balance for here will be 0. And then the next thing is that, is this 0 sufficient to meet the demand for the next period, that's 180? No, it is not. So therefore, we will have to do some production. How much production we can do? Our lot size is 200, which means we can only produce 200. Here, we will be producing 200 units. And with that, our projected available balance here becomes 200 plus 0 is equal to 200 minus 180 is equal to 20. Now, is this 20 sufficient to meet the demand for 100? No, it is not. We will again do some production here. How much production? This is our lot size 200, so we'll be producing here 200. Our projected available balance will become 200 plus 20 is 220 minus 110 is equal to 120. Is 120 sufficient to meet the demand for next period? Yes, it is sufficient. So which means in this period we won't be doing any production. Projected available balance will become 0 plus 120 minus 120 is equal to 0. Now we will be doing the same thing, making MPS for product B, making sure that our conditions are not violated. And remember, our conditions are that the total production for period 1, which means period 1 here and this one combined together should not be more than 200. We start with asking ourselves this question, is 150 sufficient to meet the demand for 100? Yes, it is sufficient. So which means we don't need to produce here anything. However, there is a hair in the soup. And that is, if we do not produce here anything, so for example, if we do not produce here anything, our projected available balance will be 50. And this 50 will not be sufficient to meet the next period demand, and therefore we will have to produce here something. However, we cannot produce because period 2 and 3 are already occupied. We cannot produce anything in period 2 because in period 2 here we have already produced 200 items and the maximum that we can produce is 200. So we cannot produce here anything in period 2, and similarly in period 3 again we cannot produce anything here. So these two slots already occupied. So which means if we go with this traditional scheme whereby we don't produce anything, we won't be able to make a production plan. Therefore, while our MPS for product B says that we don't need to produce anything here because 150 is sufficient to meet the demand for this one, we will still produce here. And how much we can produce? We need to produce here 200. And again, the reason is that because if we do not do that, we won't be able to continue with production in period 2 and 3 and we will have shortage. We will produce here 200. Our projected available balance will become 200 plus 150 is 350 minus 100 is equal to 250. Is this 250 sufficient to meet the demand for 120? Yes, it is sufficient. So it means we don't need to produce anything. And even if we need to produce anything, we cannot because we are not allowed. We have already reached the maximum level. In any case, so 250 is sufficient to meet the demand for 120 and our projected available balance will be 0 plus 250 is equal to 250 minus 120 is equal to 130. Then ask yourself question, is 130 sufficient to meet the demand for 100? Yes, it is sufficient, which means we don't need to produce here anything and our projected available balance will become 0 plus 130 is 130 minus 100 is equal to 30. Is 30 sufficient to meet the demand for 80? No, it is not, which means we need to produce here something, and fortunately we can produce here something because for period 4 it's empty here. We did not produce here anything and we have to produce maximum of 200 and lot size is 200, so which means we can produce here 200. Projected available balance will become 200 plus 30 minus 80 is equal to 150. Now, as you can see that all our conditions have been fulfilled. So one of the condition was that we cannot produce more than 200 in any of these periods. And this condition has been fulfilled because in period 1 we are producing 200 here, and then in period 2 and 3 we are producing 200 here, and we are not producing anything here. The production in week 4 was 0, but for product B the production was 200. So the total of this 200 and this 0 is equal to 200, so which means we did not violate any condition. And the second condition was that ending inventory must have been 150 units. So this is period number 4, that's the last period, and ending inventory is 150 units. So we need to see, is this condition met or not met? Combined together here, this is 0 and this is 150, and the total is 150, which means this condition is also met. Now we will be solving one more problem using Microsoft Excel, whereby this is our production plan and we'll be converting it into MPS using Microsoft Excel. So this is a question: the Hotshot Lighting Rod Company makes a family of 2 lighting rods. So family, which means it's about production plan, and there are 2 models, model H and I, which mean we'll be supposed to make master production schedule for each of them. Production is leveled at 1000 units, opening inventory is 500, and you can also see here it's 500 also appears here, and the plan is to reduce that to 300, which means by the end of the last period, this is our last period, when this last period ends we want here 300 at this place, and production is to be leveled at 250 units per week, which means we have to produce here 250 in each. We cannot make more than that, we cannot make less than that. We have to develop 2 separate sets of solutions for this problem using Microsoft Excel, and this is the demand or forecast for model H and model I. So this is the forecast for model H, 200, 300, 100 and 100, and this is for model I. This is our data in Microsoft Excel, and as you can see here, our opening inventory is 500 units, ending inventory is 300, which means when this period 4 ends, we are expecting here at this place our inventory to be 300. Lot size is 250, which means every time we produce something it should be 250, and this is our production plan, and this production plan needs to be translated into master production schedule for model H and model I. So for production plan, start with this formula, and that's production is equal to ending inventory minus opening inventory plus demand, and I'll be using this formula. So our production plan here, required production is equal to ending inventory, that's 300, minus opening inventory 500, and plus demand, that is 1200. Total production required is 1000. And then the next thing is number of periods. Number of periods, we have 4 periods here, 1 2 3 4. So I can write here 4, or I can also use this formula, count A, these 4, and it says that we have 4 periods. And then weekly production, which means total production divided by number of weeks, and that will be 1000 divided by 4 is 250. Now I'm going to transfer this 250 to this production plan, but just make sure when you transfer this 250 here, you only transfer values. So when you click on paste, make sure you are choosing paste values. Now the next thing is to calculate projected available balance, and PAB, again we can use the same approach, that's semi-isosceles triangle or a broken arrowhead, which means it will be equal to 250 plus 500 minus 300, and that becomes 450. And now I will drag it sideways, and with this our production plan is ready. Now we need to convert this production plan into master production schedule, and there are 2 conditions that must be met. First condition is that, as you can see here, that the production that we are doing in the production plan is 250 in each period. So we need to make sure that in each period the required production combined production of model H and I does not exceed 250. Similarly, combined production for period 2 for model H and model I should not exceed 250, and the same applies to period 3 and period 4. And the second condition is that our ending inventory that appears here and here by the end of period 4, which is the last period, the total should be 300. We will be using different combinations, so we just need to make sure that, for example, to achieve this 250, this one and this one total, it becomes 250. And for this period, I'll be using a tool that's called conditional formatting. So for example, this is total production. Total production for period 1, which means is equal to this one plus this one. So that would give me total production for period 1. I will drag it sideways. So that will give me the total production, and as you can see here, when I click on this one, it shows me that it is the sum of these two. Similarly, if I click on this one, it shows me that the formula is this one. I am combining this one and this one. And then similarly about ending inventory. For ending inventory for model H appears here, and ending inventory for model I would appear here. And therefore, the total inventory would be this one plus this one. So I'll be using conditional formatting, and that would alert me if any time these values become greater or less than 250, it would alert me by showing a red color cell. So I will select these 4 cells and I will click on conditional formatting, highlight cell rules, and I say is equal to 250. And when it is 250, I want this cell to appear green filled with dark green text. Okay, so that's one rule. Another rule is that highlight cell rules and more rules, if these cells, if the value is not equal to, then I want these cells to appear a red color or pink color, the color that's here, and I click on OK. The same thing I apply here. So our desired ending inventory level is 300. So I will do conditional formatting in such a way that for this one, if it's equal to 300, then I want it to appear as green filled with dark green text. However, if this is not 300, it is less than 300 or more than 300, then I want it to appear as red. So I click on more rules, and then I say if it is not equal to 300, then it should appear as this red or pink color. And then I click on OK. If at any point this becomes 250, which we actually want, so you see here it will automatically turn green. But if it's anything, for example 300, which we don't want, then it will become red. So that will be an indication if we are doing it right or wrong. Similarly, this one, we want ending inventory, we want it to be 300. So if it becomes 300, then it will turn green. But if it's any other thing, for example 230, that will become red. To calculate master production schedule for model H, we will start with our approach that's asking ourselves, is this PAB sufficient to meet the demand for next period or not? So here we have 200, and we need to ask ourselves, is this 200 sufficient to meet the demand for next period? Yes, it is sufficient, so which means we don't need any production here. However, there is a fly in the ointment. If we do not produce here anything, then our projected available balance will become is MPS plus 200 minus forecast, and that becomes 0. Now, is this 0 sufficient to meet the demand for 300? No, it is not. So which means we will be producing here something. And how much we can produce? We can produce 250, but 250 is not sufficient to meet the demand for 300. Although our schedule for period 1 suggests that you should not produce here anything, we will still produce 250. And then our PAB becomes 250 plus 200 is equal to 450. 450 minus 200 is equal to 250. Now again the question is that, is this 250 sufficient to meet the demand for 300? No, it is not. So which means again we need to do some production here. And if we do production here 250, and if I drag it sideways, then our PAB becomes 200. Now, is this 200 sufficient to meet the demand for next period? Yes, it is sufficient. So which means we don't need to produce here anything. And our PAB will become 0 plus 200 is equal to 200 minus 100 is equal to 100. Is this 100 sufficient to meet the demand for next period? Yes, it is sufficient. So which means we don't need to produce here anything. And our PAB will become 0 plus 100 is equal to 100 minus 100 is equal to 0. So here it will be 0. If I drag it sideways, it gives me 0. Now we are done with MPS of model H, and now we have to move to model I. But as you can see here, that total production we have already reached 250 for period 1 and period 2, which means we cannot produce anything in period 1 and period 2 for model I, because we have already achieved the maximum quantity that was required. So we have here 300. Is 300 sufficient to meet the demand for 100? Yes, it is sufficient. So which means we don't need to produce here anything. And our projected available balance will become MPS plus this quantity minus forecast, and that is 200. Now, is this 200 sufficient to meet the demand for next period, that's 50? Yes, it is sufficient. I will drag it sideways, and that becomes our PAB. Now, is this 150 sufficient to meet the demand for 200? No, it is not, which means we will have to do some production here. So how much production to do? Our lot size is 250. So which means we will be producing here 250. So if I produce here 250, as you can see that this cell that was initially red, it turns green. And our projected available balance will become 250 plus 150, that's 400. 400 minus 200 is equal to 200. Now, is this 200 sufficient to meet the demand for next period? Yes, it is sufficient. So which means we don't have to produce here anything. Our MPS should be 0 here. However, again, there's a problem. If we do not produce here anything, that will be a violation. As you can see here, this one will remain red because the required production level is 250 for all periods including period 4. So over here, in period 4, we did not produce anything. So which means we need to produce here anything. And the reason we need to produce here anything is that because we want an ending inventory of 300. And to achieve that 300 ending inventory, we need to produce here 250. Although just looking at period 4 suggests that we don't have to produce anything because 200 is sufficient to meet the demand of 150. However, if we do that, we won't be able to achieve the ending inventory of 300. Therefore, we will produce here 250. And if we do that, you can see here, all these, they become green, which means it says it is acceptable. Now, I will also drag this sideways. This cell also turns green. So which means all our conditions have been satisfied. We had two conditions. One condition is that total production in each period, total production of model H and I combined together should not exceed 250 in any of these 4 periods. As you can see here, this was the condition. So we met this condition. We did not exceed 250. The second condition was that our ending inventory should be 300, and we can see here it is 300. 0 here and 300 here. So together that becomes 300. So with this one, we are done with converting our production plan into master production schedule. Now the next question is this the only solution available or some other solutions are also possible? So we have the same data, and as you can see here, model H is being produced in period 1 and 2, and model I, it has been produced in period 3. We have produced 250 quantity. Now I just want to check if other variations are possible. So I'm gonna produce here 100 units. So if I produce here 100 units and here 150 units, so you see that initially these are red, which mean our conditions are not met. But as you can see, all these conditions are met, which mean we can produce here 100 and we can produce here 150, and it is not violating any condition. Our lot size is 250, which means we have to produce 250, so we are producing 250. This is 100 and 150, so that's 250. This shows that while we'll be solving these problems, we will be doing trial and error, and many variations are possible. Now let's explore some other options just by doing trial and error. And the good thing is that anytime any condition is violated, these cells will become red and we can change them accordingly. So for instance, let's say if we go for 100 here, now you can see here this becomes 350, which means our condition is violated. So let's change this to 150. It is also possible that you can also go with this variation. Now let's do another thing. If we make this 150 and change this to 100, again it says this is also possible because all our conditions are met, that we are producing 250 and our ending inventory is 300. As you can see, in this case, we are making 500 units of model H and 500 units of model I. But in this variation, we are making 750 units of model H and 250 units of model I. So the point is that we can do trial and error to develop different variations that satisfy all these requirements. The next thing is to develop master production schedule with different time zones. There are 3 zones. One is frozen zone, in which you do not have much flexibility. So to develop MPS, we will start with our approach that here we have available balance of 50. So is this 50 sufficient to meet the demand for 19? Yes, it is sufficient. So which means we don't need to produce here anything. And some other information is that lot size is 50 and safety stock is 0. Our MPS over here, we will not be producing anything. It's 0. So our projected available balance will become 50. 0 plus 50 is 50 minus 19 is equal to 31. Is this 31 sufficient to meet the demand for 17? Yes, it is sufficient. So we won't be producing anything here. And PAB will become 0 plus 31 minus 17 is equal to 14. Is this 14 sufficient to meet the demand for 15? No. We will be producing 50. Lot size is 50, so we'll be producing here 50. And PAB will become 50 plus 14 is equal to 64 minus 15 is equal to 49. Is this 49 sufficient to meet the demand for 25? Yes, it is sufficient. So we won't be producing anything here. And PAB will become 0 plus 49 is equal to 49 minus 25 is equal to 24. Is this 24 sufficient to meet the demand for 24? Yes, it is sufficient. So no production here. And PAB will become 0 plus 24 is equal to 24 minus 24 is equal to 0. Is this 0 sufficient to meet the demand for 23? No. So which means we need to produce here something. And how much to produce? Lot size is 50. So we'll be producing here 50. PAB will become 50 plus 0 is equal to 50 minus 23 is equal to 27. Is this 27 sufficient to meet the demand for 21? Yes, it is. So no production here. And PAB will become 0 plus 27 minus 21 is equal to 6. Is this 6 sufficient to meet the demand for 21? No. So we need production here. How much production? 50, because that is the lot size. PAB will become 50 plus 6 is equal to 56 minus 21 is equal to 35. Is this 35 sufficient to meet the demand for 25? Yes. No production here. And PAB will become 0 plus 35 is 35 minus 25 is equal to 10. And the last thing is that, is this 10 sufficient to meet the demand for 25? No. So we need production here. And production is 50 and PAB will become 50 plus 10 is equal to 60. 60 minus 25 is equal to 35. The next thing is to calculate ATP available to promise. And if you can recall, for ATP, we make this L-shaped pattern whereby L has been rotated by 90-degree angle. So let's do it here. And although period 1 is an exception here, so we know here one of the rule in ATP is that we count these customer orders before next MPS. So starting with 50, and we'll be including these two, 19 and 17, because in the next period production is being carried out. So 19 plus 17 is 36. 50 minus 36 is equal to 14. So that's our ATP. And we'll start from here. So this is 50 and then 15 plus 11 plus 9. I will stop here because in period 6 production is being carried out. So I will stop here and then this one will become 15 plus 11 plus 9 equal to 35. 50 minus 35 is equal to 15. So our ATP will be 15. And then over here 5 and 2, and I will stop here because in period 8 production is being carried out. So I will stop by period 7. So it will be 5 plus 2 7. 50 minus 7 is equal to 43. 1 plus 0, and I will stop here because in period 10 production is being carried out. 50 minus 1 is equal to 49. And then the next thing is to calculate for cumulative ATP. We'll be adding up these ones. So this is 14 plus 15 is equal to 29, and this 29 plus 43, that will be 72, and then this 72 plus 49, that will be 121. Once we have these three things, master production schedule, projected available balance, and ATP, it means our MPS is ready. Now we are doing the same problem but with a little bit variation. So over here we are using a safety stock of 10. As you can see here, safety stock is 10. In the previous example it was 0. So the safety stock means that this projected available balance, it should not fall below 10. If at any point it falls below 10, we will immediately start production. And we will start with the same question, that is this 59 sufficient to meet 19? Yes, it is sufficient. So no production here. Projected available will become 50. 0 plus 50 minus 19, and that is equal to 31. Is this 31 sufficient to meet 17? Yes, it is. So no production. PAB will become 0 plus 31 is 31 minus 17 is equal to 14. Now, is this 14 sufficient to meet the demand for 15? No, it is not. So which means we have to produce here. How much? Lot size is 50. And so we will produce here 50 units. And PAB will become 50 plus 14, that's 64. 64 minus 15, that will be 49. Is this 49 sufficient to meet 25? And remember, this is our frozen zone, this is our slushy zone, and you know the rule is that when we are in frozen zone, we only consider confirmed customer order, these one. But when we enter in the slushy zone or liquid zone, we need to consider whichever is greater, 11 or 25. So in this case, all these values are greater, so we'll be using them. Is this 49 sufficient to meet the demand for 24? Yes, it is. So no production here, and PAB will become 0 plus 49 minus 25 is equal to 24. Now is this 24 sufficient to meet the demand for next period? Yes, it is sufficient. However, we will be left with 0 here, which means our safety stock is 10, and if it falls below 10, that will be a violation. So which means we need to do production here. So how much to produce? Our lot size is 50, so we'll be producing here 50. So when we produce here 50, then our projected available balance will become 50 plus 24 is equal to 74. 74 minus 24 is equal to 50. Is this 50 sufficient to meet the demand for 23? Yes, it is. So no more production here. And PAB will become 0 plus 50 minus 23 is equal to 27. Is this 27 sufficient to meet the demand for 21? Yes, it is sufficient. So no production. However, safety stock will fall below 10 because there are 27 units. When those 21 will be consumed, from this 27 we will be left with 6, and 6 is less than 10, which means we need to do production here. When we do production here 50, and then our PAB becomes 50 plus 27 is 77. 77 minus 21 is equal to 56. Is this 56 sufficient to meet the demand for 21? Yes. No more production. And our PAB will become 0 plus 56 minus 21 is equal to 35. Is this 35 sufficient to meet the demand for 25? Yes, it is. So no production needed here. And PAB will become 0 plus 35 minus 25 is equal to 10. Now, is this 10 sufficient to meet the demand for 25? No. So we will be producing here 50 units. And our PAB will become 50 plus 10 is equal to 60. 60 minus 25 is equal to 35. To calculate ATP, we will be making that pattern that's like an L shape that has been rotated by 90-degree angle. And period 1 is an exception, so I'll be using this one 50 minus 19 minus 17, and I'm stopping here by 17 because in the next period production is being carried out, so I cannot include 15. So 19 plus 17 is equal to 36. 50 minus 36 is equal to 14. That's our ATP. And then the next one will be 15 plus 11, that is 26, and 50 minus 26 is equal to 24. And then 9 plus 5 is equal to 14. 50 minus 14 is equal to 36. 2 plus 1 plus 0 is equal to 3, and 50 minus 3 is equal to 47. Then we'll be calculating ATP cumulative. ATP cumulative will be 14. 14 plus 24 is equal to 38. 38 plus 36 will be 74. 74 plus 47 will be 121. Whenever we have all these three things, which mean we have MPS, we know about production schedule, we have ATP, we have projected available balance, it means our MPS is ready. In this chapter, we have discussed disaggregation and requirement. So the idea of disaggregation is that we need to convert production plan into master production schedule, and we need to make sure that all the conditions are met. Then we discussed MPS, PAB, and ATP, and finally we discussed all these things developing master production schedule with safety stock.